Everyone, welcome to my channel Code with Ease by Varsha. Today we are going to solve this question on linked list of how to remove duplicates from sorted list part 2. Why am I doing the part 2 and not the part 1? Part 1 is very simple, but anyway, I will just take a look quickly at the part 1 also so that we can establish a connection between both the questions. See, you're given the head of a sorted linked list and you need to delete all the duplicates such that each element appears only one, and you need to return the sorted link. So very simple, you have multiple duplicate values and you have to remove the duplicate in a way that only one of them is appearing, rest all are deleted. So we have 1 1 2, so we have two ones appearing twice, so we have removed one occurrence of 1, so ultimately we get 1 is pointing to 2. The logic behind this is, I will run through the logic behind this so that we can establish the logic for the second question also. Okay, see what we have. 1 is pointing to 1, another one is pointing to 2. And we have to have only one occurrence of this. So if my current pointer is over here, the moment this current pointer's value and current.next value is same, what I need to do is the current, instead of pointing to this, it can point to current.next. Current.next.next. So current.next can point to current.next.next. When should you do this? If the value of current is equal to current.next.value. This statement which I've written in the if condition, this denotes the condition of two values, adjacent values being duplicate to each other. So if they are equal, only then you are going to point the current's value, instead of the adjacent value, point it to the next of, like, instead of pointing to the adjacent node, you just point it to two node after. This is the logic. Or you can move your current pointer as it is. The code is already there in the GitHub description. Let me quickly show the code also. See, this is the code for this also. So what I've written is, if the value is equal, then you can point it to the two nodes after, or you move your current pointer as it is. So this is a simple logic behind this question of how to remove duplicates from a sorted list. Now, why I told about this logic is we need to understand this logic before we do the part 2 of this question, because it is related. Now what is the part 2 of this question? They are saying that you're given the head, you need to delete all the nodes that have duplicate numbers, leaving only distinct numbers from the original list. So it appears similar, but it is not actually similar. You are not supposed to keep even one duplicate number. So if you see this example, 1 2 3 is repeating twice, 4 is repeating twice, and 5. There is no trace of 3 and 4 in the resultant list. All the duplicates are removed. In the previous question, we at least had one occurrence of the duplicate. So this is the major difference between both the questions. So now let's try to understand how can we solve this. Now earlier, if two adjacent nodes were duplicate, we were happily moving forward by pointing the next pointer to the second next node, like the two nodes after. But in this case, we want no trace of the duplicate values. If we do that, we will still retain the duplicate value. So in this case, if two adjacent nodes are duplicate, we have to loop through them until they are duplicate. We'll keep on adjusting the pointers to current equal to current.next. The next question arises, what happens, what happens when there is a duplicate node? There are like multiple duplicate nodes. There are multiple duplicate nodes, okay? And how do we connect previous node with the new node? This is also another question. Like, for example, see here. Here 2 is a previous node. After 2, both nodes are duplicate. Again, both nodes are duplicate. Eventually, I want to connect 2 and 5. So 2 is over here, 5 is over here. In between, every one is duplicate. Now, how do I make sure this 2 will point to 5 and not to 3 and not to 4? That is also a question. So first question was, we have two adjacent nodes, or two or more adjacent nodes rather. If two or more adjacent nodes are there, then what should we do? We said that we will loop through it like a while loop. We will have a loop until they are equal. We'll keep on adjusting the current pointer, and we take the current pointer to the last duplicate node. This is our objective for doing this. Current equal to current.next. We will take it to the last duplicate node. So that current is now standing at the last duplicate node. The second question, so first question was this, and the second question was what will happen? Like how do I connect my previous node with the new node? Or I can say that how do I connect my previous non-duplicate node with the new non-duplicate node? We eventually have to do that, connect one non-duplicate with another non-duplicate. How do I connect both of them? That is the challenge that I have. So these are the two potential questions that we have with us right now. So how do we deal with it? When we say previous node, previous non-duplicate, we understand that somewhere we need to have a priv pointer, and we of course need a current pointer which will do the actual traversal. So what are the steps that we need to take? So we have 1 pointing to 2, then we have 3, 3, 4, 4, and 5. So we have, let's say, a dummy node over here which will point to my head, and we have a priv pointer and we have a current pointer. So now we check whether current pointer, whatever current dot val is equal to the next current dot next dot val, the usual check which we were doing. If it is not equal, current can move forward and priv can also move forward. So current will come here and priv will come here. It's a usual scenario. Then we check if again 2 and 3 are equal, not equal, so current can move here and priv can also come over here. Now we see current and the current dot next are equal. It's a duplicate value. So it goes under the while loop, that while current dot val is equal to current dot next dot val. So it will go inside a while loop. Until this condition is true, it will keep moving. So if 3 and 3 were equal, so now current move forward. Now is 3 and 4 equal? 3 and 4 is not equal this time. Then it will stop. Over here, there is a condition that needs to happen. See, my priv is over here. I said current will eventually reach to the last duplicate node. So last duplicate node so far is this. Now I have to connect 2 and 3. 2 with this 3. Okay. Should I connect 2 with this 3? No. I have to connect 2 with 4. So what I need to do is priv.next should point to current.next. When it should do this? When your priv.next is not equal to current. It's an important condition. So far we have done number 1, 2 adjacent nodes are equal. We'll put it inside a while loop. Cur will keep on moving ahead. Cur has now reached the last duplicate. So we check whether priv.next is not equal to cur. See, priv is somewhere over here. Current has already reached 2 nodes ahead. There is no link between priv and cur. If it was something like this, that priv and cur were going together one after another, then this condition would not have been true. Okay. So if priv.next is not equal to cur, means they are somewhere apart. And why they are apart? Because there was something in the middle, some duplicates. Then priv should point to current.next. So 2 will now point to 4. Else, if this is not the case, then priv can happily move ahead like it was doing. Now, since this is not the case, now 2 will point to 4 and current also needs to move forward. So current has moved forward. Okay. Where is the priv? Priv is pointing to this. Again, do this check, are they equal? Yes, they are. Now again current will move forward. Now again current reached over here. Now again the same check will happen. Is priv.next equal to current? Is not equal to current. Now priv.next will be current.next. So in this way, 2, which was wrongly pointing to 4, since my priv pointer never moved, now this node, this connection is cut. Now 2 is going to point to current.next, which is 5. This is the benefit of not moving the priv and keeping it as it is where it was, only changing the point. If we had moved the priv, then it would have been wrong. So in this way, 1, 2 and 5 we are able to establish. 1, 2 and 2 is pointing to 5. We got rid of the duplicates. So this was the major condition. So if I have to just show you the code for this to get a better perspective. See, what have I done? First, we have initialized the dummy node and then the priv will be at dummy. The priv is at dummy and current will be over here at head. Okay. Now we are iterating through the code and then we are checking this condition whether they are equal, like the 2 adjacent nodes being equal. If it is, current will move forward. The moment current comes at the position where it is the last duplicate node, then it is going to check, are priv and current apart from each other? If they are apart, like I just inverted the condition, if they're just next to each other, then priv will move forward happily. But if it is not, then priv should point to current.next, because current is still the duplicate node. Even if it is the last duplicate node, it is still the duplicate node. So current it will not point. Priv.next will be current.next.